We are not getting any kind of a satellite imagery of what's happening with 3I Atlas. 3 hours. That's how long. 3 Atlas vanished with no light, no trail and no explanation. Every telescope lost it at the same time. Then it came back. But what returned wasn't following the same path. It was almost twice as fast and none of the models could explain why. Some say it was a dust cloud. Others believe it's cracked and vented gas, but the blackout, the speed, the clean reappearance, none of it matters. So where did it go? Why did it return like that? And what exactly came back? When space went silent for 3 full hours, a confirmed interstellar object dropped off every major telescope's radar. It did not send out a signal. It did not reflect detectable light. It simply vanished. Then it came back, and when it returned it was moving much faster than before. That kind of event is not common. Objects in space can become faint. They can rotate out of view or be blocked by dust. But for a known object already tracked and studied by some of the most advanced instruments available to go silent for 3 full hours across different locations and detection systems, that is extremely rare. When astronomers first noticed the blackout, it came from a change in the data feeds. Several telescopes, each tracking the object from different positions, logged a sudden drop in signal. Specifically, the visible and infrared readings associated with 3 Atlas fell below detection limits. The first reactions were technical. Engineers checked for calibration errors. They looked at the sensitivity settings, thermal alignment systems, and local sky conditions. But the blackout had occurred across different instruments, some in orbit, some on the ground. Each operated independently. That removed most chances of this being a local issue. It was a clean drop at nearly the same moment from multiple viewpoints. What was even stranger was the timing. According to several observation logs, the drop happened very quickly. Within a minute, the object went from being well tracked to completely absent. The transition was not gradual. It was there and then it wasn't. During those missing hours, scientists had nothing to work with. There were no readings to analyze, no signals to chase. Observatories continued their scans, watching the region where the object had last been seen, but with no success. The object, by all measurable standards, had exited observation. That is what made its reappearance so hard to explain. Roughly 3 hours later, instruments picked up a familiar signal. It matched the earlier data, placing it in the expected sky region. But when its velocity was measured, it did not match previous projections. It was moving faster. Estimates suggest the new speed was close to double the earlier value. How could an object accelerate so much while completely out of view? What force acted on it during the blackout? And more importantly, why did it not leave behind any sign of that event? It is important to understand the way telescopes detect objects like 3 Atlas. They rely on reflected light or emitted radiation. As long as something in space reflects enough sunlight or emits heat, it shows up as a measurable signal. If a comet releases gas or dust, it often becomes brighter. If it breaks apart, the fragments scatter light in different ways. That makes total loss of signal followed by reappearance with an altered path highly unusual. Natural explanations were explored first. One theory involved a cloud of dust being ejected by the object itself. If the object released a dense burst of particles, those could have temporarily blocked its reflective surface from view. From Earth it would seem like the object disappeared. Then, when the dust thinned out, the core would become visible again. But this does not fully explain the speed change. While dust can obscure, it does not typically cause strong directional thrust without other signs like debris trails or light curved spikes. Another idea was that the object rotated in a way that exposed a dark side toward Earth. Some comets have uneven surfaces with one side much less reflective than the other. If 3 Atlas had such a rotation, it might appear to vanish when its darker face turned our way. Then, as it continued to spin, the brighter side could return to view. But that would not explain the precise timing across multiple instruments. It also would not cause a change in motion unless the rotation was tied to a surface event like outgassing. In past comet observations, sudden changes in motion have sometimes been linked to jets of gas. When sunlight heats trapped materials under the surface, those gases can break free violently. That reaction can act like a natural thruster. Some scientists believe this may have happened during the blackout window. If a jet fired in the opposite direction of the object's travel, it could have pushed it forward, changing both speed and trajectory. However, even this would normally produce visible signs such as bright plumes or irregular tails, and none were clearly detected afterward. The working assumption in astronomy is that all things have natural causes, even if they are not immediately obvious. But this blackout, especially when combined with the speed change, has pushed scientists to rethink what can happen when these visitors pass through the solar system. The blackout was not just an observational inconvenience. It opened a gap in our understanding. And when the object returned, it raised a quiet question in many research centers around the world. What really happened during those hours we lost sight of it? Why the object that came back isn't normal? When 3I Atlas reappeared, something was different. The object was no longer moving the way it had been before the blackout. Its velocity had changed, and not by a small amount. Based on updated tracking from major observatories, it appeared to be moving almost twice as fast as it was before it vanished. It raised serious questions about what happened while it was gone and whether the object that returned was still the same in every way. Before the blackout, 3I Atlas was already moving fast. Like other interstellar objects, it was on a hyperbolic path, which means it was not bound by the sun's gravity. Its orbit was open-ended, passing through the solar system on a one-way journey. Instruments had been tracking it for days, some even weeks, logging its brightness, position, and speed. Then after the blackout, it disappeared from every telescope watching it. Once the data went dark, there was no way to monitor its path or estimate what was happening. That left a large gap in the trajectory model. When it returned, the path it took no longer aligned with the original estimates. To make sense of this, scientists turned to updated readings from high-resolution observatories. They compared the object's new position to where it was expected to be based on pre-blackout data. The difference was significant. It was not just slightly off course. It was far enough that standard explanations like measurement error or small environmental effects were not enough to account for it. Instruments from the Very Large Telescope in Chile and the James Webb Space Telescope measured the object's motion relative to background stars and confirmed that its apparent speed had increased. The shift was large enough to raise doubts about simple causes like gravitational nudges or small-scale surface reactions. In open space, objects follow predictable motion. They can speed up or slow down, but that usually happens because of large forces, gravity from planets, outgassing from internal pressure or collisions. None of those were clearly present in this case. There was no known planet nearby that could have slingshotted it, no visible gas cloud or dust tail, no evidence of impact debris. The most discussed natural explanation is outgassing. That is when a comet or similar object suddenly releases gas trapped under its surface. The release can act like a natural engine pushing the object forward. In theory, if a large enough burst happened during the blackout window, it could account for the speed change, but the issue is that these kinds of events usually leave signs. They brighten the object, scatter particles, or distort the light curve. 3 Atlas did not show those signs. It came back with a steady signal, no plume, and no change in appearance. In the absence of continuous tracking, there is always a window where something unknown could happen. Could the object have broken into two pieces? Could part of it have survived while the rest was lost, or could something else have exited the blackout zone in its place? The reason this matters is because interstellar objects are rare. Only a few have ever been observed with certainty. That means each one gives scientists a very limited chance to learn how material behaves when it travels between stars. If this object changed speed in a way that does not match known physical behavior, it could point to either a new type of natural process or to something we simply do not understand yet. There is also the possibility that the speed change is tied to rotation. If the object had an uneven shape or if it started spinning faster during the blackout, that could affect how light reflects off it. In some cases, irregular rotation combined with jet activity can create small repeated bursts of motion, but this too would usually produce visual signs, flickers in brightness, surface distortion, or trailing material. None of that was clearly seen. The object that came back may be the same in name, but the data says it is not the same in motion. And when speed changes without a clear cause, even experts start to ask different questions. The science that almost fits. When 3I Atlas vanished, then came back moving faster, the first reaction from scientists was not panic. It was calculation. Every anomaly in space is first treated as a data problem. As the logs were checked, something became clear. Multiple systems located in different places and operated by different teams had all shown the same thing. A blackout, then a shift in motion. That kind of agreement usually points to something real. So what's the most likely natural cause? The first and most widely accepted explanation is outgassing. This happens when a comet heats up and releases gas from under its surface. If the gas escapes in one direction, the object can be pushed the opposite way. This is similar to a balloon deflating and flying around a room. For many comets, outgassing is routine. It is how they form tails. It also creates jets which can shift their path slightly. Outgassing is not just a theory. It has been seen before. In 2010, Comet Hartley 2 released strong carbon dioxide jets that changed its spin. In other cases, like with Comet Pan-STARRS, outbursts caused short-term changes in both brightness and movement. With 3I Atlas, outgassing seemed like a good fit at first. The object had already shown signs of being unusually active, even far from the sun. That meant it was made of volatile material, ices, and gases that can evaporate at low temperatures. That kind of mix can trigger sudden bursts. But there were problems. A jet large enough to cause a speed jump should have created visible effects. Normally, that includes bright plumes, changes in light curve, or temporary halos of gas and dust. Observations after the blackout did not show any of those features clearly. The object came back looking stable. No increase in brightness, no visible tail, no flickering. That does not mean ouging did not happen. It might have occurred on the far side of the object, hidden from view, or the gas could have been dense but short-lived. Still, the lack of any strong visual response made it harder to accept as the full explanation. Another theory that came up was fragmentation. Comets are fragile. They are not solid rocks. They are more like icy rubble piles held together by gravity and weak forces. When a comet moves through space, especially near a heat source, stress builds inside. That can lead to cracks or in some cases full breakups. A sudden crack could cause a piece to break off, changing the balance. If a chunk separated from 3I Atlas during the blackout, it might have released energy in the process. That energy could push the remaining mass forward, explaining the increase in speed. There are recorded examples of this. Comet Shoemaker-Levy 9 broke into fragments before hitting Jupiter. Other comets have split during close passes by the Sun. In most cases, these events are followed by obvious debris fields. Pieces scatter. Trails become messy. Brightness becomes uneven. But with 3 Atlas, no fragments were spotted after it returned. The object looked intact. Its brightness was stable. If fragmentation happened, it was either very subtle or completely hidden from view. It is possible that a surface layer peeled back, exposing fresher ice and boosting reflectivity. That might account for the clean reappearance, but it does not fully explain the speed jump. A third explanation was rotational shadowing. This idea is based on the fact that comets and asteroids often rotate as they move. If an object has a darker side, may be covered in rock or non-reflective dust, it can appear to dim or vanish when that side faces Earth. When the brighter side rotates back, it seems to return. There are real examples of this. Some comets show periodic dimming due to rotation. Even some near-Earth asteroids exhibit flickering that comes from uneven surfaces. If 3 Atlas had a rotation period that matched the blackout window and one side that was especially dark, it could vanish for hours. But this also has problems. First, for an object to become completely invisible due to shadowing, its dark side must be extremely non-reflective, almost like volcanic rock. Second, the timing has to line up exactly. The rotation must be just right for the object to go dark, then return within a tight window. Also, this would not explain the speed change. Rotation does not cause an object to accelerate on its own. If the spin increased during the blackout, maybe due to internal forces, it might have affected movement slightly, but doubling the speed would take much more energy than a rotation shift could provide. Beyond these, there were smaller theories. Some looked at gravitational lensing, where the light of the object might have been bent around another mass, making it seem to vanish. Others mentioned instrument blind spots, though that idea lost ground since so many different systems missed it at once. In short, every natural explanation fits part of the story. Outgassing explains acceleration but not the blackout. Fragmentation explains the change in motion but not the smooth return. Rotational shadowing explains vanishing but not speed. Dust clouds explain signal loss but not movement. What this creates is a scenario where none of the known models fully account for both parts of the event. That is not unheard of in astronomy. New events often force models to be revised or combined in new ways. But in this case, the data gap makes it difficult to be sure which cause was the primary one. Most scientists agree on one thing. A natural cause is the most likely answer. But the reason this case stands out is because the data does not match one clean pattern that makes it a scientific outlier. Not impossible but uncommon. Was it controlled? When 3IA Atlas returned after its blackout with its speed nearly doubled, most experts stuck with natural causes. That's standard in science. But as more teams studied the data, something kept coming up. The usual explanations, outgassing, fragmentation, rotation, each made sense on paper. Yet none of them fully matched what had been recorded. That left a space open for questions. What if the object did not change course by accident? The idea of a space object being controlled or artificial is not new. It became public in a serious way back in the year 2017 when Oumuamua passed through the solar system. Professor Avi Loeb published research then suggesting Oumuamua might not be a natural object. He proposed that its unusual acceleration could be due to sunlight pushing on a very thin broad surface, something like a solar sail. That is a type of propulsion system humans have theorized and even tested in small ways. If something like that existed and was floating through space, it would not need fuel, just light. Most scientists disagreed with Loeb's claim. But what made Loeb's idea stand out was that it was based on data that didn't fully match anything else. He was not claiming aliens. He was saying the motion we saw might not be random. Fast forward to 3 Atlas. It showed some of the same red flags. A speed change that could not be easily explained. A clean return without signs of damage. A data blackout that hit multiple systems at once. These are not proof of control, but they do resemble elements from earlier events that raised questions. To be very clear, no space agency or research team has claimed 3 Atlas was artificial. There is no evidence of structure, signals, or material suggesting that. But what makes this case difficult is that the object behaved in ways that natural models struggle to explain all at once. And whenever that happens, speculation starts. There are official programs focused on this. One is the Galileo project launched by Avi Loeb in 2021. Its goal is to systematically study unidentified aerial and interstellar phenomena using scientific tools. One of its missions is to build a catalog of unusual space objects and track them using independent instruments. The goal is not to prove anything artificial. The goal is to remove guesswork and focus on data that cannot be explained by known models. Some scientists believe the speed change could be an error in measurement. That is always possible. Telescopes do not capture movement directly. They track position changes over time and compare them to models. If the gap in data during the blackout created a hole in the model, then the apparent speed change might be an illusion caused by interpolation. That means the math filled in a blank space the wrong way. But others have argued that the speed change was backed by multiple observations. If different instruments saw the same result, even after reviewing the error margins, then the change might be real. If 3 Atlas is only the third confirmed interstellar object ever seen, that makes every piece of data valuable. It is rare to catch one. It is even rarer to catch one doing something strange. If there is even a small chance that some interstellar objects are non-natural, whether built or altered, then that changes how we study them. It changes how we design instruments. It changes what we expect to find when we look at the sky. For now, there is no proof that 3 Atlas was guided. But there is no full explanation for its blackout or its speed increase either. This is what keeps this object in the spotlight because it acts like something new and that deserves attention. Why this could change everything. Most space events come and go without much impact on daily life. But every so often something behaves in a way that makes scientists stop. That is what happened with 3 Atlas. It has challenged how we understand motion observation and the rules of deep space. If the readings are accurate and this object really did go dark for hours only to return faster than before, then that one event could shift an entire category of space science. What makes 3I Atlas stand out is not only that it is interstellar, but that it was observed so closely by so many instruments. Before the blackout, it had already been monitored by systems like the James Webb Space Telescope, the Very Large Telescope in Chile, and ground-based observatories in both hemispheres. It had a confirmed trajectory and early signs of activity, including chemical data that suggested a high ratio of carbon dioxide to water vapor that made it interesting even before anything unusual happened. At the very least, this event shows that our current systems are not perfect. They can miss things. They can be surprised. And when they are, we need to respond quickly. Whether the blackout was caused by dust, rotation, a surface event, or something still unknown, the fact remains it happened. And when the object returned, it came back changed. Teams are watching 3I Atlas as it exits the solar system. Some are working on how to predict these events better. Others are focused on building the tools to reach the next one in time. But all of them are paying attention now. Because when something from another star passes through our sky and then does something unexpected, we only get one chance to learn from it. And this time we cannot afford to miss it. Thanks for watching. See you in the next.